So you can go ahead. This is actually from your textbook, so you don't have to write the whole problem down. You can just write down page 382, number 6, and you can look in your textbook to see this problem. A carnival game offers a $100 cash prize for anyone who can break a balloon by throwing a dart at it. It costs $5 to play, and you're willing to spend up to $20 trying to win. You estimate that you have about a 10% chance of hitting the balloon on any throw. Now, this is going into chapter 16, so we're talking about creating a probability model. So to create a probability model, we have to know what all the different outcomes are. So what are the different possible amounts, your net win or your net earnings? So we're going to start by thinking about the possible outcomes. So again, you're going to play until if you win, you stop, but you're going to keep playing until you've spent $20. Well, how many times? If you don't ever win, how many times could you play if you stop after you've lost $20? 4 times. So 4 times is the most because it costs you $5 to play. So let's say, and I'm gonna call this a random variable x on my chart. So my random variable x is going to represent the different amounts, the net earnings. So I'm going to have x equals, and we use a capital letter to represent our random variables. So I'm going to have x equals, if you play 1 time and you win, okay, first of all, you can't play 0 times. You have to play at least once. But if you play 1 time and you win, how much money do your net winnings, your net earnings, how much will you make? 95, because it cost you $5 to play, but then you are winning $100. So that would be $95. Okay, if you play the first time and you lose, and you play the second time and you win, you have spent $10 to play and you win $100. So that means overall you win 90. Okay, if you play 3 times, and you win, then you've spent $15 and you win 100. So that gives you a net earnings of 85. If you play 4 times and then you win on the 4th time, then it costs you $20 to play. You win $100, so you get 80. And if you play 4 times and you don't win, then you've lost $20 and you don't have any more money to play, so you lost $20. Your net earnings would be -20. Okay, so these are the only possibilities that we could have for this situation. So those are the values my random variable x could take on. So now what I want to know to create a probability model, I'm still working on this, I have to know the probability of getting those values, probability of those different values for x. Actually, I'm going to write it this way, the probability of x. Okay, so now is when I have to kind of think about what's the probability of winning. Well, we have about a 0.1% chance of hitting the balloon on any particular try. So if you win the first time, what's the probability that you win the first time? Just 0.1. So I have a 0.1 right here. Okay. The only way I can get $90 net winnings is if I lose the first time and then win the second time. So assuming that each time is independent when I throw the dart, that means that the first time I lost, okay, well the probability of losing is 0.9, and then the second time I won, so I have to multiply 0.9 times 0.1 to get that probability, and we get 0.09. Easy, because 9 times 1 is 9, 2 decimal places. For this one, okay, that means I lost twice, so 0.9 squared, and then I won the third time. So can somebody, well, let's see, 0.81, move it over 1 place, so this should be 0.081. If I do something dumb, let me know, please, and don't, I think we're still good, though. Okay, then on this one, I'll need help on this one. On this one, means you lost 3 times. Oops, didn't want a decimal point there. So you lost 3 times, and then you won. I'm going to need help on that one. Can somebody tell me what that is? What?
0, 7, 2.
Okay, and then this would be losing 4 times, so 0.9 to the 4th power. I'll need help on that one too.
0.65, 61.
Okay, now what I'd like you guys to do is take a minute and add all these up on your calculator, because what should they add to? They should add to 1 if those are all our possibilities. So what we just created here, this chart, is called a probability model. Okay, again, you have to have a random variable, and capital letters, common ones are X, Y, and Z, and just like in algebra. And you have your possible outcomes, and then the associated probabilities that go with them. Now, the next thing we're asked to do is find the expected number of darts you'll throw. Okay, so we need to know how many darts is it going to take to do this. Now, when I go through this, and I didn't put the number of darts on here, so I'm going to just squeeze in a little column there. To win $95, that was throwing 1 dart. $90 was throwing 2 darts. $85 was throwing 3 darts. $80 was throwing 4 darts. And losing $20 was also 4 darts. So I had 2 different ways that I could throw 4 darts. So if I wanted to find the expected number of darts you'll throw, I'm just going to kind of tell you the formula we're going to use. We use a notation for expected value. It looks like this. So I want to know the expected value. Actually, I'm going to call this a different random variable. Let's call this y, because I already called x my earnings. So I'm going to let y be the random variable of the number of darts I throw. Okay, so if I want to know the expected number of darts, what I'm going to do is take my number of darts and multiply times the probability. So I'm going to take the 1 times 0.1, and then I'm going to add to that 2 times 0.09, add to that 3 times 0.081, add to that 4 times 0.0729, add to that 4 times 0.6561. Okay? So go ahead and calculate that. So you should have gotten 3.439, and this would be the expected number of darts you would throw. Now, obviously, you can't throw 3.439 darts, but in the long run, I mean, that's still when you get an expected value that you think, well, you can't. Don't round it to 3. Leave it like that. Okay, when you get an answer that looks like that, just like on if you look at the census data and they say, like when they talk about the average number of children is 2.3 per household or something, obviously you don't have 0.3 of a child, but they report the statistics that way. For accuracy, we would do the same thing here. By the way, the expected value is just the same as a mean. It's just an average. So you could see these words used instead. Expected value, average, mean. You're going to do the same thing. Now there's a formula for this. Think about what we did. So to get the expected value of a random variable y, we took all the different y values, this y value times the probability of y, this y value times the probability of y. So we took all the y values, we multiplied by the probability of y, and then we added them all up. Okay, that's a formula. You will find this for expected value, and it will look like this. You'll find this on your formula sheet. Okay, so you add that, the sigma means add them all up. So we take the random variable times the probability of that random variable occurring, and then you add them all up. Okay, that's expected value. Now, the other thing we're going to be asked to find is the standard deviation. And so this is number 14 in your textbook. Obviously not much there as far as what to do. But for the same problem, we need to find the standard deviation. Now that's a rather lengthy process to do by hand. You're not going to have to do that by hand. So I'm going to show you what to do on the calculator. On your calculator, and you can kind of try it or something, but for the video purposes here, I didn't want to make this too long. But on your calculator, if you enter all your this is not gonna tell me the number of darts. This is gonna tell me the amount of winnings. Okay, so I set this problem up to do the amount of winnings. I would have to change this to 1, 2, 3, 4, 4 if I wanted to have it be the number of darts. So this is set up for the amount of winnings. So I put the amount of winnings, the outcomes in L1, and the associated probabilities in L2. Once I had that set up, I did one variable stats with L1 as my list, and my probabilities became my frequency list. And then I just hit calculate. And I got a mean value. This would be the expected amount of winnings. If you played this game over and over again, you would expect to win about $17.20 in the long run. And that's net earnings. So that would be good. We're going to play a whole bunch of times. The standard deviation is $51.49, which means there's a lot of variation in some people win big, some people lose big. Okay, that's what happens when you gamble. So that's how you could do this, the shortcut with your calculator, and it will tell you the expected value. If you look at the mean, that's the expected value. If you look at the standard deviation, that is this sigma x will tell you the standard deviation. X bar will tell you the expected value. Questions on that? So again, if you wanted to do this for the number of darts thrown, you would change L1 to 1, 2, 3, 4, 4, and then you would leave the probabilities the same and do that same process, and you could find the average number of darts thrown and the standard deviation for that.